All right, so today we're going to be looking at 11.1, which is mean, and that begins on page 809. All right, so for our real world link, it says that Tina and her friends downloaded songs for 6 weeks, as shown in the table. And so it shows that the number of songs downloaded each week was 12, 6, 10, 9, 4, and 1. How many total songs were downloaded? So I want you to go ahead and do 1 through 6, read them on your own, and then answer them and see how well you can do on your own. And then we'll pick up where we left off. Pause the video now. All right, so looking at number 1, how many total songs were downloaded? We just add up all the songs. 12 plus 6 plus 10 plus 9 plus 4 plus 1, and that makes 42 total songs. And then on average, how many songs did they download each week? We would take the total, which is 42, divide by the number of weeks, which is 6, and then we get the average of 7 per week. Now keep in mind that's not saying that every week they did 7, it's just that that's what the average is. I mean, we have weeks where they did 12, we have weeks where they just did 1. Now number 3, it says on the number line below, draw an arrow that points to the average, and then plot the number of songs, and then plot the number of songs downloaded on the number line. So I did that here. I know my dots aren't very pretty, but I did my best, okay? And then number 4 says how far below the average is 1, 4, and 6, and how far above the average is 9, 10, and 12. And so I showed that it was 6, 3, and 1, and then 2, 3, and 5. Number 5 says what is the sum of those distances between the average and the points below the average, above the average? So it's 10 because it's 6 plus 3 plus 1, and then it's also 10 because it's 2 plus 3 plus 5. And so number 6 says explain why the average is the balance point of the data. Well, when you find a mean average, it's really trying to find what is the center, the middle of all of the values. Okay, so we add them all together, divide by how many there are, and that kind of gives us our center point. It doesn't mean that it's a point that is actually one of our numbers, because 7 is not even one of our numbers. But it gives us a good average because, you know, we've got 1 day we're doing, or 1 week we're doing 12, 1 week we're doing 1. We have to find an average somewhere. All right. So mean of a data set is the sum of the data divided by the number of pieces of data. It is the balance point for the data set. So it is the balance point for the data set. And maybe highlighting would be a better idea. Balance point for the data set, and really important is to remember that it's the sum of the data divided by the number of pieces of data. So on the previous page you found that a single number to describe the number of songs downloaded each week, the average or mean, summarizes the data using a single number. So you can find the mean of a set of data shown in different displays such as pictographs and dot plots, and so let's look at those. In example number 1, it says that the mean number of representatives for the 4 states shown in the pictograph. So it's saying that in Tennessee we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Then for Kentucky we have 1, 2, 3, 4, 5, 6. And then we have for Virginia 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then for Louisiana 1, 2, 3, 4, 5, 6. And so we want to find the mean number of representatives. Notice Virginia has a lot more than Kentucky and Louisiana. So it's almost like let's take some of those extra people and move them and redistribute them around. Not that this is really truly going to say, okay, now Tennessee only has this many, Kentucky now has more, Virginia has less. It's not really saying that. We're just trying to find the mean number of representatives for the 4 states. So it's not changing what the real values are. It's just finding that mean average. So what they're saying is let's move some of these figures around to fill in some of these gaps. You notice that we have 1, 2, 3 gaps here, 1, 2, 3 gaps here. But then we'd only have 2 people to move around. So that's not the way we would need to do it. So what they say to do is let's just take these extra ones and move them around a little bit. So they're saying let's take this guy and move him right here. Then let's take one of these guys and move him right here. And then we can take 2 of these guys and move them right here. And so then we're all going to be at 1, 2, 3, 4, 5, 6, 7, 8 representatives. Again, that's just the average. That's not really saying that now Kentucky has 8 representatives. They still only have 6, and same with Louisiana. But if we're trying to find the mean average, then we're going to try and make them all similar. And so 8 is that magic number, 8 representatives. And that's just a pictograph to be able to see what that looks like. It would be the same idea with our text messages. If we had, drawn little phones to represent our text messages, and we have every week we have so many, and then we would move some around and say, okay, well, we take this one here, we put this one here. I'm just doing an example. This means nothing, this drawing I'm doing. But it's just like the same thing. And then we'd say, okay, well, every week we're about 7 then. Again, it's just the average. It's not changing the data. So including data, it says even if a data value is 0, it should still be counted in the total number of pieces. This is the biggest thing that happens when we're doing mean average. So the biggest problem is that people see the 0 and they think, oh, it doesn't count. Well, just because it doesn't add anything to your list, if you had like 0, 1, 3, 6, and 5, and you add them all together, sure, the 0 is not, important to the adding part, but when you're dividing, you count it as one of the values, one of the pieces, as they like to say, the pieces of data. So when you go to divide, you're going to say, okay, I've got 1, 2, 3, 4, 5 values, so I'm going to take 15 divided by 5, and my average, my mean average, is 5. And so again, 0 didn't count for anything when I was adding, but it does count when I am counting how many pieces of data I have. That's really important that you remember that. Super important, okay? I can't tell you how many people get things wrong. If you divide it by 4, you're going to get the answer wrong, right? It's not going to end up being 5. So please pay attention to that. So example A says the table shows the number of CDs a group of friends bought. Find the mean number of CDs the group bought. And they say they bought 3, 4, 6, 0, and 2. So go ahead and test out your knowledge here. Do A, pause the video now, and when we come back, I'll have the answer. All right, so hopefully your answer was 5 CDs. Again, we added them up. We got the answer of 15 divided by 5, which is just a really weird coincidence. That's the same answer as the example I just did before. All right, so 5 CDs is the average. You've got a day where you got 6. You had a day where you had 0. Oh my gosh, I'm such a bonehead. That's 3. Was anybody freaking out on me the last time when I just said that? Hello? All right, pretend like that didn't happen. 3. All right, so this is 3. And so when I'm looking at the numbers, I've got 3, 0, 4, 2, and 6. 3 is my average that, some days I'm getting more, some days I'm getting less. Okay? But 3 ends up being my average when I add all my numbers together and divide by 5. Were you guys all freaking out on me? I bet 2 of you were. All right. Number 2 says the dot plot shows the recorded high temperatures for 6 days in Little Rock, Arkansas. Find the mean temperature. And so if you see the 2 dots, that means that there's 2 values of 45. So make sure that you're writing those out. We've got 45 plus 45. Then we have 47. Then we have 49. 50, and 52. And so how many values is that all together? 1, 2, 3, 4, 5, 6 pieces of data are there. And so we add all these up and we divide by 6. So 288 divided by 6 will be 48. So the recorded high temperatures for a 6 day, the mean temperature is 48 degrees. All right, dot plots. In dot plot, individual data values are represented as dots above a number line. So this was an example of a dot plot, in case you haven't seen that before, where they give us, oh, sorry, I did not mean to do that. I'm trying to erase. Where they give us a line, a number line, and then they show the dots to represent how many values land on that point. So looking at example number 3, the dot plot shows the number of runs a baseball team had for each game of 4-game series. Find the mean number of runs for the series. So we've got one that's at 1. Oops, let's find a marker that works. One that's on 1, one that's on 2, and then 2 that are at 4. So one of the games had 1 run One of the games had 3 runs and another 2 games had 4 runs each. So when I'm finding the sum of the data, I'm going to do my 1 plus 3 plus 4 plus 4, because this represents 1, this is represent 3, and then each of these are representing 4. And so when I add those up, I'm going to divide it by the total number, which is 4. So we do 3 plus 1 is 4, plus 4 plus 4 is 12. 12 divided by 4 is 3, and so the mean numbers of runs for the series is 3 runs. Alright, so this one you're going to do on your own. Go ahead and pause the video now. When you come back, we'll go over the answer. Alright, for B it says that the dot plot shows the number of books Deanna read each week of a reading challenge. Find the mean number of books she read. So she's got 1 book, 3 things of 3 books, and then 2 things of 4 books. So if I'm adding these up, on the top I'm going to be doing 1 plus 3 plus 3 plus 3 plus 4 plus 4, and then counting the amount of data points I have, 1, 2, 3, 4, 5, 6 will be on the bottom as my divisor. And so I'm going to add this up, 9, 10, 18 divided by 6 is 3, apparently is the magic answer here. So the mean number of books she read is 3 books each week. Okay, although some weeks she read 4, 1 week she only read 1. The mean average, the best summary of these numbers for a single answer would be 3. Alright, the mean is sometimes described as the balance point. Explain below what this means using the data set 2, 2, 3, 8, and 10. So I want you to think about that. If we're talking about the balance point and we're looking at the mean, first of all, find what the mean would be, and then let's figure out what the mean would be for this data set, and then let's determine how does that mean the balance point. And I really like how they did that in the first example we had, where they said to draw the arrow. Where is it at? Right here. I really liked how they did it right here with the back on that first page where we did number 3 and we did a number line and drew the arrow at the average and then plotted all the points so you can see it all. Alright, so go ahead and work on that. Pause the video now. We're working on the stop and reflect. Thank you. And when you explain, please do so in sentences. Alright, so when I looked at it, what I figured out was that the mean would be 5. And the way that that's the balance point is if we looked at the scale, the number line, and we had graphed the 2s, the 3, the 8, and the 10, and you figure out, you know, the distance that each one is from, just like we did on number 3 in the first example, or the real life example, you'll see that the difference between all of the sets is 8 from that center point, which is our mean of 5. And so that really balances out the scale. I know it's a weird scale because there's 2 that are lopped into the 2 and 1 for the 3, but it does all come together. Alright, example number 4, the number of minutes Marielle spent talking to her on her cell phone each month for the past 5 months were 494, 502, 486, 690, and 478. Suppose the mean for 6 months was 532 minutes. How many minutes did she talk on her cell phone during the 6th month? This is the question mark. And what's funny is that this is actually how I used to figure out what grades I needed on my final exams to be able to get the best grade possible in my college classes, is I'd set up something like this and I'd say, okay, I want my average to be blah, 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 and then I would figure out whenever you take all of these added together, divided by the amount of them, how would I need to get like that 90% to get that A. And that's because I was lazy. But I was willing to put in the math work to be able to figure out what I could do, the minimum amount I could do. So when we add up these points, we're going to get, okay, I'm looking for it, 2,650. And what we figure out is that we're going to have 2,650 plus X, and we know that we want this to be divided by 1, 2, 3, 4, 5, 6 amounts for the 6 months that they speak of. And so, and then we want it to equal 532. So what they automatically did was they took and they did the two-step equation up front, and they said, okay, well, let's go ahead and multiply both sides by 6. Multiply by 6, and that 6 is gone. Multiply this side by 6, and so that they get that 2,650 plus x equals 3,192. And then they subtracted, and I know this looks like they did it so much easier than what I'm showing you, but I'm trying just to make sure that you see where this all comes from, because they've drawn the model, but maybe you're going to go through and actually do the equation. We would subtract the 2,650 from each side and end up saying, okay, x is going to equal 542. All right, in a perfect world, this would have been neater. So let's check it out. All right, guys, I'm going to skip over to some of the hot problems that we have in our homework. One of those being number 8, where it says the mean of the set of data is 45 years. Find the missing number for the data set of 40, 45, 48, question mark, 54, question mark, 45, and explain the method or strategy that you would use. What I'm going to assume is that each of these question marks are going to end up being the same amount. Otherwise, this is a really complex problem. So I'm going to set it up where I add 40. Actually, I'm going to do this on a separate paper so that I have more room to work. Hold on just a second. I'm going to get another piece of paper going. Alright, so I want you to get a separate piece of paper out and go ahead and pause the video and write all this down. I just think another example will be a good idea. So go ahead and do that. Pause now. Alright, and so when I added all the pieces together, I was able to combine my like terms. Remember that my x's can be combined, and x and x will make 2 x's. And then my the rest of my numbers that are constants can all be added together, and that made 232. And I know that ultimately I still need to divide everything by 7, because that's how many pieces there are, and that it needs to equal 45 in the long run, because that's what they told us in the question. They said that it was going to equal a mean of 45 years. So the strategy that I'm using is using the algebraic expression way or equation way of doing it, whereas maybe you did the 7 pieces and you put the numbers in them and you said this one's x and this one's x, and that all together it's so much, and then use the same example, that same model that we used for example 4, but not my way of doing it, actually using their method. And that's 100% fine as long as you understand how to do it. My way of thinking is that I'm going to do the algebraic way. And so I'm going to now put together my, I'm going to get rid of my 7. I'm going to do my two-step equation here. And I'm going to get rid of my 7 by multiplying both sides by 7. And so the 7 is gone, and I'm left with 232 plus 2x is equal to 315. And then the next thing I need to get rid of will be my, let's give myself my t-chart here. I will get rid of my 232. And if you need a review on how to do two-step equations, because I know that even though the book wants us to do it, it's not something that we physically learned in class, Miss Palyuka has a video that I've liked on my page that you can watch on two-step equations, and she has a really cute little story that she does with it, and it's adorable. Even though she's my nemesis, I support her. So now I've got, alright, so at this point I know that those two x's, those two question marks, are going to equal 83 years combined. Now, I'm assuming that they're the same number, otherwise I'm not sure why they presented us with two question marks that weren't the same. So I would go ahead and divide by 2 at this point to finish off my two-step equation, and you would get 41.5. Alright, I'm not sure if this was paused the whole time I just said that. My 6th period class got to hear it at least, and hopefully you guys can just read over my work here and figure it out if I didn't go over it. We can talk about it in class if you'd like. So these are just some extra examples that you guys can do if you want to just work extra, and we can check them in class tomorrow. working on number 7, number 9 for the hot questions, and then also that power up that's on the back just above the those old review problems that's on the back of that page. The power up is number 15 and 16. You can work on those as well for extra practice, and we can go over them during class. Just remind me. All right, guys, have a great day. See you in school.